At geometrical isomer, don't forget we have structural and stereoisomerism. Structural consists of chain, position, and functional group isomerism, while stereoisomerism can be divided into geometrical isomerism and optical isomerism. Yeah, we already learned about geometrical or distance or easy. Now it's our turn to learn about optical isomerism. Okay, for a compound can make the optical isomerism, there's a requirement. The requirement is this compound should have a chiral center. What is chiral center? Okay, chiral center is the carbon that attaches to 4 different groups. Okay, so 4 different groups around this C. So let's say H, Cl, Br, CH3, for example, like this. 4 different groups. So this is called chiral center, and sometimes you should draw asterisk at the top of this C to show that this is the chiral center. Okay, if the compound contains a chiral, then it can make the optical isomers. What is optical isomers? The molecules that mirror images each other. Yeah, mirror image, and they cannot superimpose. Yeah, so what is optical isomer? Okay, optical isomers are molecules with same molecular formula and structural formula and has chiral center. Okay, or non-superimposable image, mirror image. Okay, so that's the definition of optical isomer. Okay, now let's draw the optical isomer of, let's see, this is an alcohol, yeah, C2H5, CCH3, HOH. Okay, to draw optical isomer, you should draw in tetrahedral form. Okay, I already told you at the first video of how to represent a 3D formula. Okay, you can see that you should draw the solid wedge to show that this bond come out from the paper to the observer. Okay, and then this is the dash. That means this bond going in the paper, and this is solid line. So this is this line show about the bond, yeah, on the plane. Yeah. So this is how we draw the 3D formula in tetrahedral form. Okay, let's say we have C2H5, CH3, H, and OH. Yeah, 4 different groups. So this is have a mirror image. How to make mirror image? You should put the imaginary mirror, okay, like this, and you should flip. Yeah, you should flip the groups. Yeah. Let me open the C2H5. Let's say CS2, CS3, like this. Yeah. Or H2C, H2C, CS3, and then this is OH, this is H, and then this is CS3. Okay, this is the mirror. Okay, now let's see the dash in initial molecule, yeah, more to the right, right? So now it is go to the left. Okay, understand? This is to the right, this is go to the left. This is to the left, the mirror image will to the right. Okay, so you can draw like this. Okay. Okay, next, This is OH, yeah, becomes HO. Don't forget, yeah, of how you flip this. This is still H, CS3, S3C becomes CS3. How the carbon connect to the carbon. How about this? CH2 and then CH3. Yeah, H3C, CH2. Okay, this is the mirror image for this compound. Okay. Okay. These two mirror images are known as enantiomer. Okay, so enantiomers are molecules that mirror image each other. Enantiomers. They cannot impose each other. Yeah. So like your left hand have the mirror image, your right hand, but you cannot impose each other. Yeah, since they are different. Okay, enantiomers are optically active. So if you put this compound in polarimeter, they will produce different rotation. Yeah. Okay. Once again, enantiomers are optically active. Okay, this is polarimeter. Okay, a polarimeter consists of a light source. Yeah, two polarizing lenses, and between the lenses, a tube to hold the sample. Okay, this is the observer. Okay, the enantiomer will rotate light, yeah, by the a particular angle. Okay, it depends. It can rotate the light clockwise or counterclockwise. It depends. Okay. Okay. Once again, this is the better picture. Okay, if the analyzer has to be rotated clockwise, the enantiomer is said to be dextro-rotatory or D-isomer. Okay, so sometimes this is raised in in saccharides, yeah, sometimes in glucose, yeah, in fructose, yeah, etc. So if it is a D-glucose, yeah, so you should put yeah small d in the bracket, yeah, to show that this is glucose that rotate the light, yeah, clockwise, yeah, or it can be a laboratory or yeah, rotated counterclockwise, L glucose. Okay, D form and L form. But if the both enantiomers are present in equal amount, they will cancel the rotation because 50% will rotate clockwise, 50% rotate counterclockwise. Yeah, in this case, these mixtures appears to be optically inactive. And this such of mixture known as racemic structure. Okay, once again, what is racemic mixture? Racemic mixtures is a solution that consists 50% of dextro-rotatory isomer and 50% the levo-rotatory isomers. So it is optically inactive. Okay, enantiomers will have different properties. Okay, such as asparagine. This is amino acids. One enantiomer tests bitter, while the other tests sweet. Yeah, so you can see that enantiomer have different properties, and this is very important in drugs world. Yeah, I mean in pharmacy. For example, a very famous drugs to combat morning sickness in pregnant mothers, yeah, known as thalidomide. Okay, the thalidomide, yeah, act as a sleep inducing, but the S1 has teratogenic, and this is responsible for fetal abnormalities. So can you imagine that if yeah, a mother that wants to combat morning sickness, and then she consumes thalidomide, and if the drugs consist of the S isomer, can you imagine what the effect of the babies? Yeah, instead of she can sleep, yeah, the fetus will grow abnormal. This drug released in 1958, and in 1959, severe side effects begin to appear. Okay, and the problem, becomes rise, and then it is withdrawn from the market in 1961. Okay, what's the result of the babies of mother consumed thalidomide? Like this. So, enantiomers, same molecular formula, same structural formula, but one rotate the light to the left, or to the clockwise, I mean, the other counterclockwise. They have different properties, very different effect. Such as in thalidomide, one effect for the morning sickness combat, but the others for responsible for the fatal abnormalities. So it is very, very important for pharmacists to separate the R isomers to the S isomers, or D and L isomers. Okay, so that's the real world problem that we can see because of enantiomers. Okay, let's practice. Explain the meaning of the term optical isomers. Okay, it is molecules with same molecular and structural formula. That's the first point. Okay, molecules with same molecular and structural formula. And then the second point, for it has a chiral center. Okay, or different spatial arrangement. Or has no non-superimposable image. Non-superimposable mirror image, or different arrangement in 3D, yeah, or different spatial arrangement. Oh, you can choose one, yeah, has a chiral center, or has non-superimposable mirror image, or different spatial arrangement. Okay. The rest is about practice questions, yeah, but I need you to practice for this. Okay, let's see the answer. CHBRCLF. So it is connected to 4 different groups, right? Please see how to make the 3D dimension. Yeah, the 3D formula. Let's say if I want to put here BR, yeah, it's okay if you want to put anywhere, yeah, since all connected to C. So let's say this BR, this is CL, this is F, this is H, it's okay. Yeah? Mirror image. Yeah, the most important, yeah, you can draw the mirror image, yeah. BR, CL, this H, this F.